Despite the rapid acceleration of artificial intelligence, our daily interaction with these systems remains largely confined to a single, static interface, typing a prompt into a chat box and waiting for a response. We rely on this baseline intelligence for complex pattern recognition, everything from unlocking a phone with a facial scan to algorithmically sorting through millions of data points for a media recommendation. But that familiar generative interface represents a hard engineering limit. It operates on a strict single inference loop. You ask, the system answers, and the computational process halts completely. Increasing model size is only part of the solution. Advancement in this field is now defined by a move from reactive generation toward proactive execution. This chart plots system autonomy against task complexity. We are going to trace the software evolution across 3 specific stages, starting at generative AI, scaling up to AI agents, and finally reaching agentic AI. We will map the precise software mechanics and architectural boundaries that separate these 3 distinct operational states. Ultimately, achieving computational autonomy is an engineering and orchestration problem. It requires building the right software environment around the model. This block diagram isolates a base layer of generative AI. At the center sits a large language model, functioning as the computational brain. Its primary function is straightforward. It ingests a prompt, processes it, and generates an output, whether text, an image, or code. That isolated flow exposes the first hard architectural constraint of the system. It is entirely reactive. The software sits perfectly dormant until a human manually initiates a query. The compute job then terminates the exact millisecond the output generation is complete. It has no continuous active state. The second structural limitation is its isolation from live data. The model operates within a fixed boundary defined by its pre-training data. September 2024 becomes its strict knowledge cutoff. Because of this barrier, the brain cannot natively retrieve current information. Ask for today's gold price, and the query fails without external help. Confined by a reactive design and severed from real-time data, this base layer possesses exceptionally low autonomy. It makes 0 independent decisions. Without access to external databases or the ability to run internal cyclic loops, a generative AI model is highly capable at parsing text, but remains a static, isolated encyclopedia. To bypass those constraints, developers build a specialized software shell around the core LLM brain, creating an AI agent. The first modification is tool integration. We engineer data pathways linking the brain to company databases and public APIs. The LLM shifts to a dynamic router. It evaluates prompts, recognizes its knowledge gap, and actively triggers external tools to fetch missing information. Rather than relying solely on the frozen weights of its pre-training, the system pulls live, untrained data directly into its context window to solve the problem at hand. Equipping the model with this external tool access bridges the gap between a closed-loop answering machine and an entity capable of interrogating its outside environment. External tool access enables data retrieval, but a functional AI agent also requires internal sequencing through multi-step reasoning loops. Consider a standard customer support case where a user asks the agent, "Where is my package?" The system must independently query the internal shipping database, authenticate the specific user ID, retrieve the delivery status, verify that data internally, and finally formulate a cohesive reply. The system sequences these discrete steps continuously and automatically. The user does not manually prompt the system to search the database and then prompt it again to read the result. By wrapping the base model in external tool integrations and continuous reasoning loops, AI agents transform the LLM into an autonomous problem solver, highly effective within the tight boundaries of a specific task. There is a strict operational boundary between completing a narrow, specific task and achieving a broad, open-ended goal. Agents are task-focused. Agentic AI is goal-focused. We can view individual agents as highly specialized software engineers. Agentic AI acts as the comprehensive tech team, complete with a project manager overseeing the workflow. A highly complex objective containing multiple variables cannot be solved by a single prompt or executed by a single isolated agent. An agentic AI framework provides the macro-level routing architecture. It takes a massive goal, divides it into discrete, manageable tasks, and assigns those subtasks down to the specialized agent nodes. Agentic AI functions as a macroscopic system architecture, managing the high-level collaboration between these individual AI nodes. Let's trace a complex scenario, such as the directive, "I have a budget of 500,000 rupees. Invest in gold when conditions are favorable." First, the Market Monitor node continuously pulls financial APIs to track price fluctuations. Identifying a favorable drop, it fires a data packet to the Financial Advisor node. This node analyzes portfolio rules to determine the exact budget allocation and passes those finalized parameters downward. Finally, an execution agent interfaces securely with a brokerage API, places the actual purchase order, and pushes a confirmation notification directly to the user. Wiring this complex data transfer together requires dedicated industry frameworks, such as Microsoft AutoGen, Crew AI, or LangGraph, to act as the architectural glue between the nodes. By structuring agents into a collaborative network, the system strips away the need for human micromanagement, achieving complex, multi-domain goals autonomously. This graph maps the progression of system architecture. Generative AI forms the foundational layer, powerful pattern recognition gated by a reactive closed-loop design. AI agents occupy the specialized middle tier. By integrating external APIs and internal loops, they break out of that reactive state. Agentic AI represents the highest framework, networking those agents to orchestrate massive, open-ended goals. Generative AI answers. AI agents perform. Agentic AI orchestrates. Across all of these paradigms, the underlying large language model remains the raw computational engine. The surrounding software architecture dictates whether that brain acts as a static encyclopedia or a proactive, autonomous operator.